Hi, my name is Sharon Freeman, and today we're going to talk about cell structure. My cell structure class is based on the standards for the 7th grade science. But before I begin, we should talk about the two people that made it possible by inventing a cell theory. Now, they didn't invent a cell theory. It's more like they came up with it. They went to dinner. The two men that are involved in this, I should start with that, because that is the beginning, is Theodore Swain and Matthias Schleiden. If it wasn't for them having dinner together and talking about what they were both working on at the time, because remember, when this was going on in 1837, there were a lot of things that we have today and take for granted that weren't even invented then. The first thing that we should look at is there was no electric light bulb. There was some electric light, but it was mostly gas-lit. And we didn't have restaurants to go to. So they probably had dinner together in someone's house or in a small home restaurant. Now, talking about 1837 is pretty interesting because the things that were invented had been Braille, metal cans, although the can opener wasn't invented until 1850, which is kind of strange because they used to have to use a hammer and a chisel to open cans. The first kindergarten opened in Germany, the push lawnmower, Morse code, and the compound microscope. Now, the reason that I even brought this up and feel it's important is that the compound microscope was not like the microscopes we use in class today. The microscopes we use in class today are usually 60 times to 100 times magnification. What that means is that the things that are placed under the microscope will look 60 times magnified. The compound microscope back in 1837 was only 3 to 9 times. So it was a lot more difficult for people to look and see actually what was going on inside a tissue sample. So this is important to remember because these two men both were master microscopists, which means they had lots of experience using a microscope. And Mr. Schleiden was a German botanist, and he studied plants. And Mr. Swain he discovered a digestive enzyme called pepsin in 1836. So just the year before they were having dinner, he discovered pepsin, which is important in our digestive system to break down food. He examined animal tissues under the microscope, mostly tadpoles. Now, both of them together, when they sat down to have dinner, really probably didn't think much that they were going to come up with a major breakthrough in biology. But they did. I imagine the conversation went something like this. So, Matthias, what have you been working on? Oh, you know, looking at plants, trying to figure out what makes plants, and what are the building blocks of plants. Really? Because when I look at the notochords of tadpoles, I've discovered that they're all made out of these small parts called cells. Really? Well, I discovered long ago that all plants are composed of cells. Do you think it's possible? I don't know. Are you thinking what I'm thinking? Yes, I am. I think that all plants and animals are made of cells. I think you're right, but let's investigate it further. So they investigated further and both looked at each other's samples and decided, after many, many, many observations, that all plants and animals are made up of cells. But what is a cell? And why is it important? Well, each living creature, plants and animals, are made up of cells, and cells are little building blocks that make up a plant or an animal. Let me start by showing animal cells. An animal cell, a typical animal cell, would look like this. Of course, cells look different, but may look different on the outside, but on the inside, they're all pretty much the same. Of course, plants and animals do have some differences, and we will talk about those in a few minutes. But right now, let's start with the animal cell. Each animal cell has a cell membrane which holds all the information or all the organelles. And what is an organelle? Before I go any further, we should talk about organelles. Organelles are the structures that are inside a cell, like the nucleus in this case. And all cells have nucleus, whether they're a plant cell or they are an animal cell. All cells also have a cell membrane, which holds the cell together, and it protects the inside of the cell from things that want to get inside of it, like parts of other cells, waste products, and the like. Now each cell has a nucleus, and inside each nucleus is a nucleolus. Now that is actually where what they call the DNA is stored. The DNA is what, I'm sure you've heard of DNA. If you ever watched any type of crime show where they talk about DNA, the DNA is pretty much the label of the cell. And based on the DNA is what the cell will become, whether it will become a skin cell or a muscle cell. There are many other types of cells, but they're all structured the same. Now, when we look at the cell, we also see that it has mitochondria. The mitochondria is what helps feed the cells. What it does is it breaks down sugars into proteins that are used by the cell. There's also stuff inside called the cytoplasm. Now the cytoplasm is kind of like a jelly-like substance that keeps things suspended in the cell. It's kind of like if you take a package of glitter and you put it into a jar. All the glitter will be at the bottom. But if you put water inside the jar, the glitter will be suspended. And that's how the cytoplasm keeps the cell from having all the organelles fall to the bottom. There's also what they call lysosomes in a cell, in an animal cell. Lysosome is actually where the proteins are stored until they're needed. There's also a Golgi apparatus, which takes waste products away from the cell and packages them up and prepares for them to get put out of the cell. And there's also the smooth and the rough endoplasmic reticulum, which is a fun word to say. From now on, I'll just refer to them as the smooth or the rough ER, as opposed to the endoplasmic reticulum. In a plant cell, the organelles are slightly different, although they have the same nucleus and nucleus, the smooth and the rough ER, the mitochondria, but the plant cell has this big structure that's in the middle, a vacuolar. And what that does is that stores the food and the energy that is needed for the cell to live. You also notice that it has chloroplasms. Chloroplasms are what gives a plant a green color, but most importantly, chloroplasms are used in the process of photosynthesis. Now, if you remember, photosynthesis is where sunlight is converted into energy for the plants. Once the sunlight is converted, it stores it in this big vacuolar. One of the differences, however, is that there is a vacuolar, which is different. There's the chloroplast, which is different. And there is a cell wall. The cell wall serves as kind of like an exoskeleton for the plant. Tomorrow, we'll get further into our discussion of DNA. Thank you, and have a great rest of the afternoon.